Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to do exactly what the title of the video said. We're going to use our boring head for the mill to bore a semicircle. Give you just a little bit of a backstory on this. As some of you may recall that follow the channel, several months ago I built a cart or a wagon to pull behind my zero-turn mower. The purpose of that wagon was to carry a 15-gallon sprayer tank. Used primarily to spray Roundup. I did spray a little herbicide with it back during the December. But primary use is for Roundup, to spray around the barn here. The shelters, inside the dog's playpen, various places around. If you're a homeowner with grass in the yard, you know the need to spray Roundup occasionally. But I found a bit of a shortcoming with that wagon. It worked fine as long as I kept the hose reeled up on the tank itself and left just enough out where as I was riding and spraying. But there were several places where I needed to get off the mower and unwind the hose and to walk around and spray large areas. What happened was, trying to store that hose back and take it off, I had like 3 or 4 places between here and my niece's house next door that I needed to get off the mower to do some spraying. And the hose storage was a problem. So I decided I would try to come up with something a little bit different. In this picture right here, you see where I made a vertical hose storage instead of wrapping it around the tank. The vertical rod on this is actually a piece of chain link fence pipe. Its diameter is about 1.3 inches. And I wanted to come up with a way to mount that piece of angle you see on the front there. And so I needed some standoffs. And as you can see in this picture, I made a couple standoffs out of some larger diameter aluminum, 1.875, so 1 7/8 round aluminum. I had a piece just long enough to mill that semicircle into each end and then cut in 2. So what I'm going to do today, I don't have any more of this large material that I use. I took this piece off of the rack to show it to you up close. And as you can see, hopefully you can see in the video here how good of a fit that is. Now, that being a non-nominal size, like I say, this 1.31, 1.32, I was not able to, if I had an end mill that diameter, I would simply set that end mill up and just kept plunging down and moving over a little bit at a time to get the desired depth. Don't have an end mill that big. For the purposes of this demonstration today, I'm going to use some smaller material. I've got a piece of another little piece of galvanized here. Probably a piece of conduit, but it measures 0.93 on the outside. 925, 926, probably 925. And I've got a piece of just aluminum round stock here that's 1 3/8. What I want to do today is show you how to use your boring bar to bore a less than half or a semicircle into that side so that we can mate these 2 pieces together if we wanted to. So let's turn now to the over to the mill. Okay, in order to get the best match possible between what we'll call the upright here and the standoff, we need to get the boring head set as close to the offset on the boring head to be as close to the radius of this piece as possible. The closer we are, the better fit we have. So what I'm going to do, I just found this piece of material over in my parts bin. I'm hesitant to call it a scrap bin, but we all got those type bins. But what I've done is I'm going to take this piece right here, bore a hole in it that is just a bit smaller than the diameter we're looking for. So we'll start with of course, a starter bit. All right, there's the center, or there's the centered up on the little witness mark we made. So I'm going to lock the table on the X and the Y axis now, and we'll drill us a starter hole in here. All right, now I'm going to take the drill chuck out and put the boring head in with the table locked in place just like it is. Then the boring head will be centered up on this hole. Okay, I've got the boring head in now, and I've got the tool in it set to where it just matches the hole we drilled. Now the material we're shooting for is 0.925, seems to be about the center. It's not perfectly round. We're going to shoot for maybe 0.92, plus or minus a few thousandths. Remember, all we're doing now is using this test piece down here to get the boring head at the right diameter. All right, I'm going to just keep creeping up. Like I said, we're shooting for about 925, 920, 925. All right, that's 0.921. I'm going to unlock the y-axis, bring this out just a little bit. Remember, I marked or set 0 on the DRO. And that's just, I could force that in, but I think that's good just like that is. We can always advance this a little bit if we need to once we get on our actual workpiece. So this test piece here has served its purpose now. We can get it out, we're done with it. And we're also done with what the y-axis setting was. We'll keep the Z. We'll keep the X. All right, I think I'll lay a parallel across the bottom of that. And we want to be absolutely certain this is good and tight in the vise. Now I'm going to have to take the boring head back out again and put the drill chuck in and get it centered up on the Y. But remember, we're good on our radius here, so I'll actually tighten that down just a little bit. We're good on the diameter set up on the boring head, meaning that the it's offset exactly half of what this is. Alright, so now we have the center located on the y-axis, the center of our, what would be our standoff here, not our test piece. I'm going to put the boring head back in and bring it right back. Alright, the boring head is back in now, and remember we're centered on our y-axis, and that is locked down good and tight. Lock our head down good. Now I'm going to bring this down and just gradually ease in, and just till I touch. Alright, I'm going to zero out the x-axis on the DRO right now. Now, this piece was 0.925. Half of that, let's see, is 463 thousandths. I don't want this piece, or just like in this case, I didn't necessarily want this standoff to go all the way, about a third the distance. So for this, I'm going to start with about 300 thousandths and see what that fit looks like. All right, so we're at 0 right there. On the DRO, or on the y-axis, I'm going to move one turn of my table, which is 100 thousandths. I'm going to lock that down. I think this would work in steel just as well as aluminum, but I probably wouldn't go more than about 20 thousandths at a time with this tabletop mill. All right, let's go another 100 thousandths. And as I said before, if I had an end mill, the exact diameter of our piece here, I'd be doing this with an end mill, or even if I had a drill bit. But for purposes of this demonstration, I don't have one that would match that. So we're using the boring head. Another 100 thousandths. All right, let's do a test fit. Now, if we hit on this outside edges before we're hitting in here, that means our radius set on here is not enough and we will need to advance that out. If we're hitting in the bottom and not touching on the sides here, it means that we're too small. Too large, I'm sorry. And I got to jack that up a little bit. That is why when I was making this other one, I cut just a short piece, but I don't know, I don't want to cut that off right now. So I want to be sure none of the burrs on here are getting in my way. And that looks like we may be touching just a little bit on these outside edges here. See if I can get some of those burrs off. Okay, I used this little emery board here and got the burrs off around the bottom and on this trailing edge here as well. And I think that's probably, you guys can't see it, I'll show you the end result, but I think I want to go another 100 thousandths deep. All right, I'm going to take one more look at it. See if that's about the depth I would want. I think so. So what I'm going to do, I'm going to carry this piece over to the dirty side of the tin boring on the Scotch-Brite wheel and just clean up these edges a little bit. Okay, I carried it over to the Scotch-Brite wheel, cleaned off the burrs on that trailing edge and under the bottom. And hopefully you can see it in the camera what kind of fit we got there. Excellent fit. Now if I were going to make a couple of standoffs, of course I would have this in faced off to the same diameter. I'd turn it around in the vise, do another one, and of course it wouldn't matter if this was clocked to the same, because if we're making two standoffs, we would cut it in half to begin with. It's just much easier to hold when you got a long piece stock. I've watched thousands of machining videos on YouTube and don't know that I've ever seen anybody using a boring head to do a pocket like this. But I can't imagine I'm the first one to think of that. So I'm sure there are other practical uses for it other than just the standoff that I made for the hose reel or hose storage. Maybe door handle standoff, something like that. In any case, I hope you got a little bit out of this video. After I made that piece for the sprayer tank, I got to thinking about it might make an interesting video. So again, I hope you found a little interest in it. Y'all take care, and I'll see you on the next video.